Hi everyone. In the given problem statement you have to solve, search in a rotated sorted array. So we are going to given an integer array of num which is sorted in ascending order with distinct values. So it's been written here, right? We must able to write an algorithm which solves in big O of log n runtime complexity. So you have to find the target element in this sorted rotated array, right? So whenever we see a value of big O of log n, right, we can easily assume that it can only be solved using a binary search. So a question might arise, right? Let us take this example: 4, 5, 6, 7, 0, 1, and 2. So the initial value, right, if it was a sorted array 0, 1, 2, 4, 5, 6, 7, right, it would be very easy for us because we can apply a binary search out here and we can get the results, right? But in this case it would be a little bit complicated. We have to use a modified binary search. How is that going to work? Let us understand. So like the normal cases, we are going to have our left pointer, and which is going to be 0, and our right pointer, which is going to be length of nums minus 1. In this case, right, 0, 1, 2, 3, 4, 5, 6. So it would be 6. So the mid, right, it right now L is this one, this is the R. So mid would be plus 0 divided by 2, it would be 3, right? So we can say the mid is 7 for the time being. So this is the mid, and our target element, right, is 7. So you have to find, oh sorry, our target element is 0. So you have to find this. Now a question might arise, right, how we are going to sort it up. So we are going to check, right, after the normal sorted has been happening, right, we are going to check that if our if nums of mid is greater than or equal to our nums of 0. So in that case, we can assume, right, if nums of mid is greater than nums of 0, because the array is rotated only one time. One time in a sense that it is rotated in a sequence. So we can say that the left side is basically sorted. Okay. So if the left side is already sorted, right, it's already in a sorted order. So we can do a binary search between inside here. So here, right, we can check if. So for the ease of our understanding, instead of 0, right, let us write here L. So I can say, right, if nums of L is less than our target and it is less than equal to nums of mid. So in that case, what we are going to do, we are going to say R equal to mid minus 1, because the value, right, is present in between this range. Okay, so if the target is within this range, right, so obviously we have to decrement our right pointer to then this range, right, it will be mid minus 1, else it would be L equal to mid plus 1. So in this case, right, because this is not the situation, right, our target value is not present in this range, right, we are going to increase the left by mid plus 1. So now our left pointer, right, is going to be at this index, and our new mid, right, it would be 4 plus 6, which is 5. So our mid would be in this position. Okay, so once we have got the mid, right, so our mid is in this position. Now we are going to check, right, again we come out here and we are seeing that the mid is greater than our nums of 0, right, we can say the array is already sorted. Now is our range, right, is within this range that you have described out here. If it is within this range, right, in this case, if you look into it, right, it is within that range. So we can say r equal to mid minus 1. So if r is mid minus 1, so r value would be 5. So 4 plus 5, the mid value would become around, no, it would be mid plus 4. So mid would become in this range, right? So we are going to get this value. And there will be another condition, right? In case we are not in the sorted part, right? Or the right side is sorted, right? We can say if nums of mid is less than target and is less than nums of mid plus 1, or it's, no, it would be r, right? So in that case, we can say, or we can safely assume, right, the value is on the right hand side. So we can say L equal to mid plus 1, or else R equal to mid minus 1. So that's the basic idea, right? You have to find out which side of the array is sorted. So that would be the basic principle of doing it. Now in this case, right, we are going to increase or decrease our mid values, and our mid is at this position, right? And we are able to see that our value is less than it, right? So after we get all those values, our initial mid is going to be this point. So it would be 0 1 2 3 4. So it would be index 4, right? So if you're able to get the index 4, so in that case, what we can write on the top of it, right? If our nums of mid is, if it's equal to target, then we can return the index which is going to be mid. And in case, right, if this entire loop works out and it is not still able to find it, right, we can return -1. So that would be the basic principle or the idea. And if I run this entire code, right, it will be go of log n. Sorry for my handwriting, I think I've written a lot of basic principles, but if I write the Python code, right, I'm pretty sure you'd be able to understand the principle on how this is working. Now let us jump to the Python solution. So the first thing we're going to do, we are going to create our left and right pointers. So left would going to be 0 and right would be length of nums -1. So while our left is less than equal to r, we're going to find the mid. So mid would be basically L plus R double divide by 2, so that we get an integer point value. And now we're going to check if the mid value that we got, right, if it's equal to target. So if nums of mid equal to target, then we can return our index because we found the mid value. Now two things, right? So if our left side is sorted, left side sorted, so in that case, right, how to find it out? So if nums of L is less than equal to nums of mid, in this case we can write less than also because it's been given, right? All the values are going to be distinct, but still it's for the sake of simplicity, let me write less than equal to. Now we're going to check few more conditions. If nums of L is less than target and target is less than equal to nums of mid. So if it's in that region, right, so we can safely assume, right, the value is present on the left hand side, right? So we can say R equal to mid -1, else L equal to mid plus 1. There could be another condition if the right side could be sorted. So if nums of mid less than target less than equal to nums of R, so in that case we can say, right, the value is present on the right hand side. So L would be mid plus 1, or else R would be mid minus 1. And in case, right, if you're not able to find the value after iterating through this entire loop, right, we can just say return -1. Now let me run the code. There is one error, it seems. Let me check. Yeah, so I found a small mistake that I have done, right? So here, right, it would be nums of L less than equal to target, and target should be less than nums of mid. Okay, let me try to run it now. I hope it should work. Let me check. And for the sake of simplicity, let me write one more comment out. Right side is sorted. Now let me submit the code. I hope it should work properly. As you could see, the code ran successfully and it is betting 100% of the submission, and the code ran in big of log n time complexity, so it's pretty efficient. That's all for this video. See you in the next one.